welcome everybody, and I will talk a little bit about univariate and multivariate data, and also about multivariate data analysis. So the learning outcomes of this lesson, short lesson, the first one is to distinguish between univariate and multivariate data, these two concepts, okay? And the second one is to understand the concept of multivariate data analysis, or what we call chemometrics. That is, we will learn what is the definition of chemometrics through some examples, okay? And we will talk about the concept of latent variable, that for us is really important, okay? So let's go to the first point. We are all scientists here, right? And actually, I would like to ask you, before starting my speech, one question. How many of you use multivariate data analysis every day? Raise your hand. One there. And three. Because my target in this lesson is twofold. First of all, to demonstrate you that you use multivariate data analysis every day in your normal life. And secondly, that to demonstrate you that you may need multivariate data analysis or chemometrics in your research. Okay? So, univariate data. We are scientists, as I said before, and we usually go to the lab, and from our samples we gather data, right? Look at this example. Imagine that we want to quantify some samples by measuring the pH. What we do is go to the lab, we have our samples, we have our pH meter, and we take the pH. After that, we make a regression line like this one, and we can quantify, right? Whatever, analyze using the pH. Look at this. For one sample, we take one data point. This is what we call univariate data, as simple as it is. What happened with this perspective? Imagine that you are involved in a study of obesity, and you are told to check the height and the weight of the people, right? You take the height of 200 persons, you calculate the mean, and you establish some control limits. And here you have these points of each people, right? Look at this green point here. It seems that this guy is in the boundaries, right? In the limits. Let's see what happens with the weight. We do the same. We take the weight, and we put in a graph, we calculate the average, and we plot all these guys with respect to the average. Look at the same guy. He's inside the control limits, right? But what happens if now I take these two variables and project one against each other, against the other one, like this? Look, we all know that weight and height, more or less, they follow a linear relationship. The taller you are, the more weight you have, right? But suddenly this guy is out of boundaries. You see? What happens here? As I usually say, there is nothing wrong if you are 2 meters tall. There is nothing wrong if your weight is 50 kilos. But for sure, there is something wrong if your weight is 50 kilos and you are 2 meters tall. You see the difference? In this case, taking one variable, we don't get all the information. Taking only the height, for us, all the people are healthy, or they are not obese. Taking only the weight, the same. By taking both together, it looks that this guy is not as healthy as we expected, right? So when we gather, for one sample, we gather more than one variable, this is what we call multivariate data, okay? This is what we have here. For controlling obesity, we need at least two variables. And we have to use these two variables at the same time, okay? In this case, we talk about multivariate data. I have here some examples. For instance, in spectroscopy, we have one sample, and we record the whole spectrum of this sample. What do you think? This is multivariate or univariate data?
Multivariate.
Multivariate data.
You're taking the full spectrum for one sample, so you're taking one sample and taking
Exactly. For one sample now, we will use the whole spectrum, okay? If we take a lot of samples, we have a lot of spectrum, okay? Also another example, we have in engineering, when they are making a reaction here, a chemical reaction, they have a reactor and they put a lot of sensors there, right? That is, the reactions are controlled with time. For one point time, that is, we take this reactor, we take one sample out, and we measure all these things. pH, temperature, concentration of some products, conductivity, this picture. That is, for each point, we measure like 3 times 515 variables. This is another example of multivariate data. For one data point, we have a lot of information, a lot of variables. Okay? These are these two examples. And basically, to handle this data, this multivariate data, what we use is multivariate data analysis. Okay? But before going there, one activity. I want you to think by yourself about your data in the lab, and after we will make a kind of discussion about if your data is multivariate or univariate data, or if you have some examples in which you have multivariate data. Okay? Around 3 minutes to think, and we can continue discussing. You can talk each other, eh?
It's three-dimensional.
Yeah, that's how we do it. If it's given how many things, if you take one piece less than that. Yeah, in practice it's different anyway. It's also
Okay, let's make a brainstorming, okay? So, any ideas?
Yeah, we have experimented that there is a soil part of the land which is treated by different fertilizer for many years. So we check the effect of like 5 fertilizers on the diversity of microbial cells at different time points.
We have soil.
Yeah.
Okay, and for checking this fertilizer effect, you measure something.
So the soil is treated with different fertilizers.
Mm-hmm. Fertilizers. And what are the variables that you measure there?
Then we have the time,
Mm-hmm. Time.
and we have the microbial diversity.
Microbial diversity. So you see, for one sample, that's your soil, you have some variables there, the fertilizer, time, and the microbiological diversity.
Yes.
Some other examples?
I calculate the electronic properties of the superconductors.
Mm-hmm.
And there is the coupling to the electrodes and the molecular geometry. And of course the bias voltage and stuff like
Mm-hmm.
this.
Okay. More examples?
so I basically one example is that I'm working with density measurements. So
Mm-hmm.
so it's basically an image that's each pixel value is a density measurement.
Mm-hmm. Okay. So as you see, you are surrounded by multivariate data. What is this because? Why is this why? Because nowadays for each sample we try to gather as many data as possible, right? We have fancy machines, especially for instance if you are working with chromatography. Any of you are working with chromatography here? No, but with chromatography you can gather a lot of information about one sample. Okay, and sometimes it's really annoying to manage all this information, right? So that's the reason why we use multivariate data analysis. Okay? What is multivariate data analysis? I prefer call it chemometrics. And the first thing that I will say is the definition. But my definition, my particular definition. Chemometrics is a word composed by two words. Chemo, that indicates chemistry. But in general, we can say that is science. And metrics, right? That indicates measurements. That is, all the mathematical or metrics things that we can use to extract all the relevant information from our data. Chemical data, physical data, simulation data, whatever data. So, mathematical tools to acquire more knowledge of the data sets in many diverse fields of research by using, and this is important, this is the main difference with univariate analysis, by using all variables at the same time. Okay? That is, the examples of before, obesity, we have to use two variables in this case, in this example. In the reaction control, we will use all the variables that we collect for each time. In a spectrum, we will use all the information in the spectrum for all the samples at the same time. And also in your examples, you can do the same. Okay? And this of chemometrics, as I told you before, is a little bit old-fashioned word, because I don't like this chemo. Because chemometrics has been applied in many diverse fields. For instance, environmental chemistry, physics, analytical chemistry, nanoscience, biology, whatever. Okay? So the big two questions. What we gain with chemometrics? We can find latent variables or patterns between different samples by using, as I told before, all the information available for each sample simultaneously. And now it comes the big question. What is the concept of latent variables? Okay? So to illustrate what is a latent variable, let me put you an example. You know who invented chemometrics? The psychiatrics people. Okay? How come? Imagine that you have to classify all these people, okay, by using only variables that you can measure in their faces. What can you measure in their faces?
Eye color.
Sorry?
The color of their eyes.
The color of the eyes?
Yeah, hair color, skin color.
Male or female?
Can you measure male or female? This is a really nice question. You will see after. This is really nice.
Shape of the face.
The shape of the face, the length of the nose,
Or just the dimensions. Yeah.
a lot of things. You see? With all this information, for each person, that now it becomes a sample, we can create a table like this. And this is quite similar to the tables that we have in our labs, right? Sample, Jonas, and this is the length of the nose, the length of the ears, lips, hair, whatever. Okay? These are variables that we can measure. Okay? If we apply chemometrics, we really like to represent this analysis in fancy plots, in b-dimensional plots. For instance, for this analysis, I did it and I obtained this. What can you see here?
Skin color.
A skin color.
Yeah.
Skin color from the top
And no
to
female.
the bottom.
No female.
Male, female. Females here, males here, right? That is, we can separate between male, female, women, men. And sometimes we have problems with some people only measuring the face, or measuring the things that we can measure in the face. Actually, it's quite complicated to decide whether this is a man or a girl. And also, as you said, the color of the skin. Somehow, we can classify the people having here light colored people and dark colored people. And now it comes the main question that is joined with your response before. Look, we have found two latent variables. For sure there are more. And the main question is, can you measure the gender or the race of one person by measuring only the length of the hair? No, right. That is, the gender, we can distinguish each other because we take a lot of variables at the same time. We know for sure that this is a male. Well, not for sure, only looking at the face. And this is a female, right?
Yeah.
Because in our brains we analyze, okay, this has this length of hair, this has these nice lips, this guy has this big, I don't know how to say, checks, and also the eyelashes and eye. So we can do it. That is, by analyzing the variables that we can measure, we can find information about other variables that we cannot measure, like gender and race. And this is exactly what we call latent variables. Okay? The latent variables explain all, or almost all, of the variability sources in our data sets that cannot be explained by considering the variable-to-variable behavior. And as I told you before, you use multivariate data analysis every day. For instance, can you tell me who is this person here? By looking at the eye? Almost.
He's a man, yeah, and he could be the one playing,
Look.
yes, what's his name?
Christian Bale?
He's
Christian
an
Bale,
actor.
no.
He's an actor.
He's an actor.
Yeah,
I used to be an actor, but really bad actor. Look now at the nose.
Connery or something? Is his name Connery?
Sean Connery.
Yeah, I think he looks like Sean
Close to Sean Connery. Now with the nose.
No.
And now?
Yeah, now he doesn't look like Sean Connery anymore.
Okay. And now?
Oh!
You see, immediately you have recognized this guy.
Yeah.
And he was a really bad actor, by the way. But you recognize.
If you show the hair, then we will know.
Yeah. But this is important because there are some variables that we can measure that are more important than other ones. If I show you the hair, probably you come with more ideas closer to Elvis Presley. James Dean, for instance. Okay? So this is pattern recognition, and we use this every day in our life, and this is multivariate data analysis. That is, when you see someone on the street, mentally you measure a lot of things to give a response. Oh, this is my boyfriend, or this is my girlfriend, or this is my friend. This is multivariate data analysis, because we cannot really measure this. So now, as an activity, you have to tell me what kind of latent variables you use every day in your life. Think deep, and you can talk each other. I will give you another clue, okay? Beauty is one of the most important latent variables in the life. Because when you are in the park, having a walk, and you see a guy, you can say, he's a handsome guy. You cannot measure handsomeness. You don't have a ruler, okay, you are 70, handsome. You cannot say that. But you see the guy and you say, he's a handsome guy. Why? Because mentally you are measuring, okay, he's 170, he's black, and probably he's from Spain. So he's a handsome guy. Okay? These are things that you can measure. So think about these things. So,
Whereas this ribbon, that's,
Yeah.
any example?
Taste in, for instance, food.
Exactly.
Music.
Taste is a latent variable because when you taste an apple and you say, I like this apple, first of all you like the aspect of the apple in the shop, and after you like the taste in your mouth, that this is sour, that this is with a lot of water, and if the apple is mature, not mature. These are all things that you can measure, but at the end you give an answer. Taste. I like it, or I don't like it. And you have another one.
Yeah, this was tasting food, but there's also tasting music. We talked about because you can sort of measure the rhythm or whether there's harmony or whatever, but whether you like it or not is an individual.
Yes. More examples?
Smell.
The smell could be.
Because it could be a combination of different factors that will get whether it is like the overall outcome is acceptable or not.
And it is curious the smell because I made some olfactometry 1 year ago, and it is curious that the people who work in olfactometry in the smell, they smell the individual smells of the things. And I was smelling chocolate, and the chocolate pure, we like the smell of chocolate. But if we check the individual smells, they are really, really disgusting. Shush, gasoline, yeah. Rotten cheese,
what?
really. But all together, give us a really nice response. Okay? Good point. More things?
Have some weird thing, like ownership.
Ownership.
Yeah.
Explain?
Well, I can look at a particular shoe and I will know that it's either my shoe or another bad shoe, you know. That,
But what can you measure to say that this is my shoe or not my shoe?
yeah, well, you can't measure it in that way. But,
That's looking at
but
the...
there's a recognition of the thing.
Yeah.
But then, you know, I will still know even though I saw, you know, another copy of my shoe in a shop.
That's right.
You have to measure, you know, the surrounding or whatever.
Yeah, that's true. Imagine that this is my bag, and I know that it's my bag. If there is another bag exactly the same as mine, I can recognize mine because there are some things in my bag. Like, for instance, this is broken here, and all these things. So I can recognize that it's really my bag, with things that I can measure. Okay? So you see, you are surrounded by multivariate data analysis, pattern recognition. And this is what you have to apply now to your data. For instance, here we talk about obesity, right? We cannot measure obesity, but we can measure the height, the weight, the cholesterol, this size of the arm. We can measure a lot of things to say, you are obese, you are not obese. In a spectra, we usually measure all the spectra, and after the analysis, we get a response. We can separate between apples and pears, for instance. In reaction control, we can say when a reaction is ending, because we are measuring a lot of variables that are telling me that it's about to end. This is another latent variable. You see? So, to summarize this small lesson about multivariate data analysis, the main benefits of Chemometrics multivariate data analysis. The first one is that you can obtain a lot of knowledge about your data with a little effort, of course, data analysis, but you will gain a lot of knowledge about your data. And usually, it's really nice to see that you have bunches and bunches of data about one sample, and at the end, with one graph, you can classify your samples, okay, by using all this information. Imagine that in the reactor you have to go variable by variable, making plots and cross plots. It's gonna be crazy, right? So this is the main benefit. You gain knowledge of your reactions, and also you will save time, money, and resources with Chemometrics. Instead of being like 2 weeks making plots of all your variables and cross variables, you can make this analysis, and in one fancy plot, you have the response. Okay? So, I encourage you to use Chemometrics or Multivariate Data Analysis. And now if you have any question, it's more than welcome.
What can you buy it?
What?
Buy it?
No, but you can go to our webpage
Yeah.
and check it.
Yeah. Thanks.
Okay.